Okay, section 6, factorising. Not going to go over the common factor much. I'm going to concentrate more on the difference of two squares and trinomials. Okay. However, it is worth mentioning that the first thing you would do for any factorising is take a common factor. So if we're doing factorising, always think, can I take a common factor first? I'm not going to go over loads of examples on that though, because it's quite straightforward. And from there, we're then looking, do I have a difference of two squares? Do I have squares? Or do I have a trinomial? Okay. And if I've got a trinomial, is it an x squared, or is it a number in front of the x squared, 2x squared or 3x squared? Okay. And this is obviously the slightly harder version of things. But that's what we should be thinking about factorising. Take a common factor and then do a difference of two squares. And that's always written in the form, a squared take away b squared. Okay, so for example, it could be x squared take away 9, something like that. But there's two terms, not the three terms which you get with the trinomial. That's where the tri comes from, three terms. Okay, so it'll be x squared plus 2x plus 1, 2x squared plus 4x plus 5. Okay. But we should always try and take a common factor out first if we can. Okay. So let's go through a few questions and we'll see how we get on. So this is our most basic type of trinomial, and it's got a 1 in the middle. Well, sorry, 1 in front of the x squared, and there's obviously not a common factor I can take out of here as well. So we're going to solve this. This is standard trinomial. So we're looking for a number that adds to give us minus 11. I hate when it does that. Adds to give us 11, and multiplies to give me 24. So let's look for multiples of 24 then. So obviously 1 times 24 gives me 24. However, if I add them together, I get 25. I could do 2 times 12, that gives me 24. If I add them together, I get 14, so not minus 11. I could do 3 times 8, and that gives me 24. And if I add them together, I get 11. Okay, so I'm thinking this is sounding good. So how do I get this to add to give me minus 11, and this to still give me 24? Well, let's do 2 negatives. 2 negatives still make a positive. Okay, so this is a winner. So simple, all I'll do is write x minus 3 and x take away 8. Okay, simple as that. Those numbers go in here. Don't forget u equals 0. And we did talk about this in class. We were saying that what we're actually doing here is trying to solve the point at which our parabola crosses the x-axis, or crosses the x-axis here, because that's the point where the equation equals 0. Okay, so whatever value of x I put in, the y value, obviously this y-axis there, comes out as 0, because we're working out the coordinates of these 2 points. Now, that point is usually enough for factorising, but if I want to actually solve the way this question is asking, I then need to say, okay, well, at what point does this equation equal 0? Well, to make this equation 0, one of these brackets has to be 0. So how do I get this bracket to equal 0? Well, when x is 3, that bracket will become 0. 3 take away 3 is 0. How do I get this bracket to be 0? When x is equal to 8. Simple as that. So what you've said there is that your coordinates are actually over here. At 3 and 8, that's where the graph cuts the axis. Okay, to go into that in a bit more detail, what I've really said there is x take away 3 equals 0, and then I've rearranged, and x take away 8 equals 0, and I've rearranged as well. Obviously, if one of these brackets is 0, then the whole thing becomes 0. If that's 4 and this is 0, then it's still 0. Okay. So those two numbers, this equation holds true. Okay. So add to give you this first number, multiply to give you the second number. Nice. Factorise this and then simplify. Okay, so we should be thinking here, common factor, can't do it. Okay, and then we're thinking this has only got 2 terms, so it's not a trinomial, it's a difference of 2 squares. So a difference of 2 squares, a squared take away b squared. I can rewrite that in the form a take away b, a plus b. So in this case, a squared take away b squared, I've got 4x squared take away 25. So 4x squared is equal to a squared, and 25 is equal to b squared. So 5 is equal to b if I do the square roots of both sides, and then 2x is going to be equal to a, because I take the square root of 4 and the square root of x. So now I can rewrite it like that. I can say 2x take away 5 and 2x plus 5. So that's me factorise this. And now it wants me to simplify this expression. Now, at this point, we can rewrite this top line as 2x take away 5 and 2x plus 5. That's fine. But they're actually giving us a little clue, right? If they want us to simplify this, something on the bottom here is going to have to equal this. So I know when I go to factorise this, one of the brackets is going to be that. Okay. So they're giving us a little clue. But this is our more difficult trinomial. Okay, so 2x squared, take away x, take away 10. So this time I'm adding to give us this number in here, which in this case is going to be minus 1. Okay, we don't write the 1, but it's there. And I'm multiplying to give me minus 20 because I'm doing the 2 multiplied by the minus 10. Okay, so what are my multiples of minus 20? Well, I could do, let's start off with 1 times minus 20. That doesn't have to give me that. I could do 2 times minus 10, not quite. 3 wouldn't go, 4. I could do 4 times minus 5. This is looking good. So 4 plus minus 5 is going to be minus 1. So it's 4 and minus 5. That's looking good. So what I'll do now is I rewrite this x in the middle as plus 4x, take away 5x, take away 10. Okay, so the 10 stayed the same, 2 stayed the same. I've rewritten this middle bit. I've rewritten minus 1 as 4 take away 5. Then we're going to draw a little dotted line, and we're going to take a common factor. So what's the common factor of these two terms here? It's going to be 2x, bracket x plus 2. And then I copy the bracket over, I say x plus 2. And then I say to myself, how do I get it from 2 to minus 10, or how do I get it from x to minus 5x? Times it by minus 5. And then I put these terms together, I put the 2x and the minus 5 together in a bracket. And I'm thinking I've done something right because that's 2x minus 5. And then I write the other bracket down, x plus 2. Okay. The only thing I've forgotten is my equal signs, which I always forget, which is shocking. And technically, if I'm factorising something, I'm saying equals 0. Okay, so maybe actually instead of putting the equal signs there, I should really put, just to be fully correct, I should really write equals 0 all the way along, okay? Because when I'm factorising, I'm saying this equals 0. Okay. So now I can rewrite this bottom term as 2x take away 5 and x plus 2. Does anything cancel out? Yep, these cancel out, and I'll be left with this. So that's interesting. That's got you to factorise twice in this question. You've got the difficult trinomial and the difference of two squares. So yeah, we're kind of equating the a squared minus b squared to this, and then we're square rooting both sides. And for this one, probably the hardest bit, again, finding your multiple, so doing 2 times minus 10 to get the minus 20. So then working out which two numbers multiply to give you minus 20, but add to give you minus 1. And then doing our technique where we break up the equation into 2, and we take a common factor, and then we put the 2x and the minus 5 together, and then we write the x plus 2. Okay. Nice one. Time for just one more, I think. Okay, so fully factorise. Can I take a common factor? Absolutely. I can take 3 out, and that's going to be x squared minus, so again, if you're not very good like me, just do your equation. Just do 48 divided by 3, so that's 1, carry the 1, 3 into 18, it's going to be 6. Okay, so that's x squared minus 16. This looks like a difference of two squares, so I'm saying that the x squared is a squared, and the last bit is the b squared. So a squared is equal to x squared, so I could write a squared equals x squared, and b squared is equal to 16. Square root both sides, a is equal to x, and b is equal to 4. So I could rewrite that as 3, x plus 4, x minus 4. And if you want to check that's right, you could do a little check on the side, say x and 4, x and minus 4, you get x squared, 4x, minus 4x and minus 16. These cancel out because they're plus and minus, so you're left with that term, so that's right. Yeah. So you just double check it as well if you want. So this one's got a common factor, and then you're doing your difference of two squares. Easy.